Section 3.3, proving lines parallel. So what we're doing is we're going a little bit of the opposite direction from section 3.2. 3.2, the given was that the lines are parallel. Well, now we're trying to prove the lines are parallel. That hypothesis is switching with the conclusion, which means we are using converses. And we have a postulate, something we accept as true without any proof, the converse of the corresponding angles postulate, that if two corresponding angles are congruent to each other, then the two lines are parallel. So really taking that if P then Q and switching it from the previous section. Now what's very important here is the parallel postulate, okay? The parallel postulate. What this says is there is a point P right there, and it is not on line L. What Euclid said is that through point P, there is exactly one line that's parallel to L. It is unique, okay? And it's important that we have that uniqueness. That means there's only one way that that dotted red line can be parallel to L through point P. That uniqueness allows us to deductively say that these two lines are parallel and these two lines only. Okay? Euclid's parallel postulate really sets it apart from all the other geometries out there. Your spherical geometries, your hyperbolic geometries. The parallel postulate is truly unique to Euclid's. All right? So because of that converse of the corresponding angles postulate, because of the parallel postulate, we get all of these theorems. And really, I mean, these theorems are not too different than what you saw in section 3.2. Okay? We have the converse of the alternate interior angles theorem. You have a pair of alternate interior angles congruent, boom, lines are parallel. We have the converse of the alternate exterior angles theorem. You have a pair of alternate exterior angles that are congruent, boom, the lines are parallel. We have the converse of the same side interior angles theorem. You have a pair of same side interiors that are supplementary, boom, your lines are parallel. Okay? So it's all the same ideas, we're just flipping the order around. So if you are looking at a proof that has the prove statement that two lines are parallel, that means you need to be using a converse theorem or a converse postulate. So let's take a look at example 1, okay? We have P and R are parallel to each other. It's good to know. Then we have angle 1 congruent to angle 3. So marking up that diagram, okay? And then let's go ahead and write all this out. So our two columns. P is parallel to R, angle 1 is congruent to angle 3. That is our given information. So let's use our givens. Lines P and R are parallel. If we look at P and R, how can we use that information? Okay, I'm looking at angles 2 and 3. Those are alternate exterior angles. So angle 2 is congruent to angle 3 by the alternate exterior angles theorem. Alt-ext angles thumb. So, use a different color here. 3 is congruent to 2. Well, look at that. 1's congruent to 3. 3 is congruent to 2. You know what? I think angle 1 is congruent to angle 2. By some transitive property of congruency. And if 1 and 2 are congruent, those are corresponding angles. We have a pair of corresponding angles that are congruent. That means that the two lines are parallel by the converse of the corresponding angles postulate. All right, get a pair of angles congruent or a pair of same-side interiors supplementary. You can use your converse theorem or postulate to prove the lines are parallel. So you can take a look at example 2 and check my completed notes online.